Hi Ninjas, in this video today we are going to talk about the corticobulbar tract. Let's get started. Alright Ninjas, so when we talk about corticobulbar tracts, we have a couple goals. One, to discuss where they begin. What's their origin? Then, what's their destination, the endpoint? Then, what is the function of the corticobulbar tracts? Okay? And then what we'll do is we'll draw out the corticobulbar tract kind of in a step-by-step process in two views. A sagittal view and then a coronal view. Okay? So first things first. What is the origin of the corticobulbar tract? Where does it begin? And that is your motor cortex, right? The motor cortex. Now the motor cortex is made up of a bunch of different areas, right? One of those is your primary motor cortex. Your primary motor cortex. Do you guys know where the primary motor cortex is? It's on your precentral gyrus. This contributes about 30% into your corticobulbar tracts. The other one is called your motor association cortex. It's called your motor association cortex. And your motor association cortex is made up of two of them, right? Your premotor cortex and your supplementary motor cortex. And they both contribute 15%. So 15 for premotor, 15 for supplementary. That's a total of 30% to the corticobulbar tract. And the last one is going to be your primary somatosensory cortex. And if you guys remember, this is the one that's on your postcentral gyrus. And it's on the parietal lobe. And this accounts for approximately 40%. Okay, 40% of the corticobulbar tracts. All right, so we have an idea of where the origin of the corticobulbar tract is coming from, motor cortex wise. But then if we dig down a little bit deeper into that primary motor cortex, take a coronal section, from that motor cortex, where on the homunculus, right? So if this is our homunculus, that little man that we look at, the motor homunculus, what portion of that homunculus would be here? Well, here you're going to have where the legs are, right? So this portion right here would be your legs, your lower extremities. This portion right here would be the trunk. This portion right here would be the upper extremities. And this last portion here that we're going to circle, this is where the head, the neck, and the tongue muscles are all supplied. That's where that's going to originate. So when we talk about corticobulbar tract, it's from these motor cortex areas, but from the what? The most lateral and inferior portion of that motor cortex is where it begins. Beautiful. So we know the origin. The next component here is talking about the destination. Where do these corticobulbar tracts eventually go to? They're going to go down somewhere and synapse on something. What is that destination? What is this point here? The first point that you need to know is it's going to synapse on the trigeminal nerve nucleus. So what is the trigeminal nerve nucleus? This is cranial nerve 5. And cranial nerve 5 supplies what? Your muscles of mastication, right? So this is your trigeminal nerve. Okay? So that's one that we're going to start with, your trigeminal nucleus. The next one that it's going to go down and synapse on is going to be cranial nerve 7. And this is your facial nerve. And what does your facial nerve supply? Your facial nerve is going to supply the muscles of facial expression, the motor output, right? So that's your facial nerve. The next nucleus that it comes down to is actually a big old nucleus, okay? We give this nucleus a special name. It's called the Nucleus Ambiguous. Now you're probably like, well, Zach, I thought we were kind of getting into a trend here where we were hitting specific nerves. Well, the nucleus ambiguous is actually the nucleus of 3 particular cranial nerves. One is cranial nerve 9. And cranial nerve 9 is your glossopharyngeal nerve, right? The other one is cranial nerve 10, and this is going to be for the vagus nerve, okay? And the last one here is going to be cranial nerve 11, but particularly the cranial part of the 11th nerve, which is your accessory nerve. So this is called your accessory nerve. So the nucleus ambiguous is the nuclei of 3 particular cranial nerves, glossopharyngeal, vagus, and accessory. That's another destination point. The last true destination point is going to be the hypoglossal nucleus. So it's going to be the hypoglossal nucleus, and this is cranial nerve 12. So this is called your hypoglossal nucleus. Now, Some people might say, well, Zach, I read in textbooks that it also supplies cranial nerves 3, 4, and 6. It does, but not directly. Corticobulbar tracts go directly from the cortex to these cranial nerves. But for cranial nerves 3, 4, and 6, it's an indirect connection, right? How is it indirect? Well, it's corticobulbar tract to two particular structures. One is called the paramedian pontine reticular formation, and the other one is called the medial longitudinal fasciculus. These interact with the third nerve nucleus, the fourth nerve nucleus, and the sixth nerve nucleus. So when we say corticobulbar tracts, these technically are not a part of the corticobulbar nuclei, okay? If we're really being specific. Okay, that covers our destinations. So we understand the origin, the destination points. So if we focus on the destination out to whatever structure it's going to, it should be relatively simple, right? So think about the cranial nerve 5. Well, we said that's the trigeminal nerve. What does that supply? I don't want to know every single muscle. I just want you to tell me that muscle group. It's the muscles of mastication. That's your chewing muscles. That's one thing that it's going to be involved in. So the corticobulbar tract is involved in that. The next thing is it also innervates cranial nerve 7. What is that nucleus? That's your facial nerve nucleus. What does the facial nerve supply? That supplies the muscles of facial expression, right? I don't want to know every muscle, I just want to know that group. So it's the muscles of facial expression. Bunch of muscles in that group. The next thing is the big one, and that's that nucleus ambiguous, which is a son of a gun to spell. This guy, again, is a part of what 3 cranial nerves? The cranial nerve 9, which is glossopharyngeal, cranial nerve 10, which is vagus, and cranial nerve 11, which is particularly the cranial part of 11, which is the accessory. All of these combined supply what things? It supplies the soft palate muscles, bunch of those. It supplies the uvula, the punching bag in the back of your throat, the pharynx, and the larynx. And there's a bunch of muscles that are involved in that. The next thing that there is involved in is the hypoglossal nucleus, which is cranial nerve 12. And the hypoglossal nucleus is involved with the muscles of the tongue, right? So if you think about this, when we talk about corticobulbar tract, it's involved in chewing, facial expression muscles, basically in your entire deglutition process, speech, and movements of the tongue. That is the function of the corticobulbar tracts. Now, let's talk about the corticobulbar tract pathway in 2 views, sagittal and coronal. So let's start with each step. If you were asked in an exam or by your attending, hey, tell me the step-by-step process of the corticobulbar tract from beginning to end. Here's what you would say. We're going to start with the cell bodies in the cerebral cortex, the motor cortex, right? From here, it's going to move down. When it moves down, it moves through this fan-like structure called the corona radiata. Then from the corona radiata, it moves down through another structure called the internal capsule. From the internal capsule, it then moves down through the midbrain via the crus cerebri. Then from the crus cerebri in the midbrain, it then moves down into the pons and then extends all the way down to the level of the medulla. Along the way, it's going to give off its collaterals to these nuclei. When it comes down and stimulates these cranial nerve nuclei, what is this type of presentation or setup, if you will? This, from the cortex to these nuclei, this is kind of what's referred to as a upper motor neuron. And then these nuclei here, these cranial nerve nuclei, all of these, they're getting information from the upper motor neuron. So these are technically all a part of a example of a lower motor neuron. From each one of these nuclei, when they're stimulated by this corticobulbar tract, it's going to activate these nerves. Cranial nerve 5. What's that going to go to? Muscles of mastication. It's going to activate each individual nerve here. What is this one? The facial. What is that going to go to? Repetition's good, right? Muscles of facial expression. It's going to go here to the nucleus ambiguous. What's the nucleus ambiguous a part of? That's a part of cranial nerve, 9, 10, and 11. Cranial part. That's going to go to muscles of soft palate, uvula, pharynx, larynx. Then the last one here is going to be the hypoglossal. It's going to stimulate that, and that's going to come out via this nerve to go and supply the muscles of the tongue. That's that pathway in a sagittal view. Now, we have to dig in a little bit deeper and talk about some ipsilateral, contralateral pathways that you can't see in a sagittal view, but you can see in a coronal view. Let's do that now. All right, so we talked about the sagittal view of this pathway. Now let's talk about the coronal view of this pathway. So again, where are we beginning? We're beginning in that motor cortex. Where? In the most lateral and inferior portion where the head, the neck, and the tongue and all those muscles are supplied. So from here, we're going to have all of these cell bodies in this cortex give off their axons. These axons are going to fan out as a part of what was that whole fanning structure that we said here? The corona radiata. Not the coronavirus, the corona radiata. And then from here, it's going to move down the internal capsule. Now this is another discussion. We didn't talk about it because you couldn't really see it in this sagittal view. But you have the internal capsule, right? And then this portion here is the anterior limb. This portion here is the posterior limb. And then this portion here in the middle is the genu. Right here in this genu, or the bend of the internal capsule, is where the corticobulbar fibers run through. Then as they run through all this, they come out here and then run where? Into the midbrain. We're only following the right corticobulbar tract. So this is the right corticobulbar tract that we're following. The same thing is going to happen on the left. We're just not showing it. Coming here through the midbrain via the crus cerebri, which is this in this area, it's going to move down through the midbrain and down through the pons. Now, as it moves through, it's going to extend. Where does it extend? Down from the pons, down to the medulla, all the way down here, right? Along the way, it's got to give off collaterals. What were those collaterals? Well, we said it gives it to the trigeminal nerve, to the facial nerve, to the nucleus ambiguous, and the hypoglossal nucleus. Here's what we didn't see in the sagittal view. We only saw one nucleus in the sagittal view. There's two trigeminal nuclei. So this is your cranial nerve 5 nucleus, both the right and the left. And the same thing is going to apply for all the ones below this. Well, the right corticobulbar tract, you know what's cool about this? It gives off axons that go to the right trigeminal nerve nucleus. That makes sense, right? But guess what else it does? It gives it off to the other one too. So it gives an ipsilateral collateral, an ipsilateral fiber, and a contralateral fiber. That's to the trigeminal. Guess what else would happen? You know how the left corticobulbar tract would also be coming down this way? It would also be giving a collateral to the left trigeminal nucleus and the right trigeminal nucleus. That's very important. So remember, corticobulbar gives bilateral to right and left trigeminal nucleus. Now, we come down to the facial nerve nucleus. It's a teensy bit more complicated. This is our right cranial nerve 7 nucleus, and this is our left cranial nerve 7 nucleus. There's two parts, right? This is the upper portion, and this is the lower portion. It's very simple. The upper portion of this nucleus supplies the upper muscles of your face. The lower portion supplies the muscles of your lower face. Why is this important? We'll talk about it in a little bit more detail later because it needs a teensy bit more discussion. For right now, right corticobulbar tract, remember we're only following the right. It's going to give off its ipsilateral fiber to the upper facial nerve nucleus. It's going to give off a contralateral fiber to the left facial upper part of that nucleus. Here's where it's just a teensy bit more complicated. The right corticobulbar tract gives a collateral only to the contralateral lower aspect of the facial nerve nucleus. That is important. We'll go into a little bit more detail of the significance of that later. But that's that part. It does not give an ipsilateral to the lower portion. Follow the corticobulbar tract down more. As you follow it down further, you come to this nucleus ambiguous. Again, it's going to give a ipsilateral connection to this nucleus ambiguous and a contralateral connection to this nucleus ambiguous. So in the same way, it supplies the right nucleus ambiguous, and it supplies the left nucleus ambiguous. And what are the three nerves associated with this? Cranial nerve 9, which is glossopharyngeal, cranial nerve 10, which is vagus, and cranial nerve 11, particularly the cranial part of the accessory nerve. So when we talk about the right corticobulbar tract, which is the only one we're following, it gives contralateral and ipsilateral supply to the corresponding nucleus ambiguous. Go down to the last nucleus, the hypoglossal nucleus. When it comes to the hypoglossal nucleus, again, you have two parts, the upper part of the hypoglossal nucleus and the lower part of the hypoglossal nucleus. The upper part supplies muscles of the tongue other than the genioglossus. The lower part supplies the muscles of the tongue only for genioglossus. This right corticobulbar tract, which is the only one we're following right now, gives off a ipsilateral fiber to the right hypoglossal nerve nucleus, the upper portion, and a contralateral fiber to the upper hypoglossal nucleus on the left side. So again, which one is this one here? This is your right, pink. This is your right hypoglossal nucleus, which is cranial nerve 12. This is your left hypoglossal nucleus, which is cranial nerve 12. The right corticobulbar tract gave a ipsilateral supply to the right hypoglossal nucleus, the upper portion, and a contralateral supply to the left upper portion of the hypoglossal nucleus. Again, here's where it's a teensy bit complicated. We have this lower portion for the right corticobulbar tract. It's only going to give contralateral supply to the left hypoglossal nucleus, the lower portion only going to the genioglossus muscle. So to simplify this, if someone were to ask you these nuclei, trigeminal nucleus and the nucleus ambiguous, from the right corticobulbar tract, it's getting bilateral supply. It's the simplest way of explaining it. For the facial nerve nucleus, it's getting bilateral supply from the right corticobulbar tract to the upper portions. Only contralateral supply, right, for the lower portion. Same thing for the hypoglossal nucleus. It's getting bilateral supply from the right corticobulbar tract to the upper portions of the nucleus and contralateral supply only to the lower portion of the hypoglossal nucleus. Why is this important that I stressed on all of this? We're going to talk about that in just a second. But again, the pathway is not over. We've taken it down to the nuclei. Once this corticobulbar tract has stimulated these nuclei, what does it do? Let's just take, for example, the nucleus ambiguous. It stimulates the nucleus ambiguous, activates the cranial nerves, which one? Glossopharyngeal, vagus, accessory, and they go out and stimulate what? The muscles of the soft palate, the uvula, the pharynx, and larynx. Same thing, stimulate the hypoglossal. This goes to muscles of the tongue. Facial, muscles of facial expression. Trigeminal, muscles of mastication. So we followed the pathway all the way from the cortex down to the destination. From these nuclear destinations, what's the overall function? Now, because these can be a teensy bit complicated, we're just going to zoom in on it a little bit and just talk about why it's so significant. We know this bilateral and contralateral supply for facial and hypoglossal. All right, so to finish up, again, I wanted to just kind of zoom in on the facial nucleus and hypoglossal nucleus because it was pretty easy for all the other nuclei. They were getting bilateral supply from one corticobulbar tract, and they would get bilateral supply from the other corticobulbar tract. Except for the facial and hypoglossal, they get kind of a bilateral and a little bit of contralateral. So I wanted to discuss that. So again, kind of expanding here. We have this facial nerve nucleus right here. This is the cranial nerve 7 nucleus. This upper portion of the nucleus is going to the upper facial muscles. This lower portion is going to the lower facial muscles. That's the first thing I want us to understand. When we look at this diagram, this black part here is designed to represent the cortex. Okay, so this is our cortex. This portion here is meant to represent the nuclei. So the facial nerve, the facial nuclei. And then here is meant to represent, obviously, the face. So what's the step-by-step process if we really kind of zoom in on it? Let's take, for example, the right cortex and then the left cortex and go step by step. Right corticobulbar tract, what do we say? It's going to come down and it's going to do what? It's going to give an ipsilateral supply to the upper facial nerve nucleus on the right side, and it's also going to give contralateral supply to the left upper facial nerve nucleus. But it only gives contralateral supply to the lower left facial nerve nucleus. Same concept. Follow from the left. From the left cerebral cortex, the left corticobulbar tract is going to come down. What's it going to do? It's going to give ipsilateral supply to the left upper facial nerve nucleus, contralateral supply to the right upper facial nerve nucleus, and then only contralateral supply to the right lower facial nerve nucleus. Why is this important? We're almost there. Let's just follow the right side in this case. From this right upper facial nerve nucleus, this is going to go and supply the right half of the upper aspect of the face. From the left, this is going to only come down and supply the right half on the lower aspect of the face. Now, if you have a lesion that develops here in the left corticobulbar tract, for example, you have less supply going to these upper nuclei, right? Because they're going bilateral. But what is compensating for that loss of supply to the upper nuclei on the right and left of the facial nucleus? The right corticobulbar tract. Your right corticobulbar tract is still intact. So it's still able to stimulate the contralateral upper facial nucleus and the ipsilateral facial nerve nucleus. So this can still fire. In other words, this can still fire and send action potentials to the upper aspect of the right side of the face, even though there may be damage to this tract. That's important. But here's what's interesting. This tract, we already covered the upper aspect. But what about the lower aspect? This left corticobulbar tract is only going to the contralateral facial nerve nucleus on the lower aspect. Do you have the right corticobulbar tract giving any supply to that? No. So because this black fibers are only going to the contralateral side on the lower facial nucleus on the other side, you have no ipsilateral supply. So therefore, this lower aspect of the right facial nerve nucleus is going to be inhibited. It doesn't have any supply. So because of that, this will not be sending action potentials to the right lower half of the face. So all of these muscles on the right lower half of the face are going to undergo either complete paralysis or weakness. What does that mean? The face will start drooping on the right side. But the upper aspect of the face on the right side, they'll be able to use those muscles and wrinkle their forehead because that tract going to the upper aspect of the face is intact because they have a contralateral supply. So because of that, why is this so important? If a patient comes into the hospital and they have a drooping of the face, what's your immediate concern? A stroke. Well, they're going to have drooping of this face. But you have to determine, is this a stroke or is this Bell's palsy? How do you do that? Well, in Bell's palsy, you take out the entire facial nerve nucleus. That means the upper part of the face isn't getting supply and the lower part of the face is not getting supply. And a stroke where you take out this upper motor neuron, the corticobulbar tracts, you still have the muscles of the upper face on the contralateral side still intact, but this lower part's damaged. So you'll droop, but then what do you tell them? Wrinkle your forehead, ma'am or sir. They'll be able to do that. And that could be a sign of a corticobulbar tract lesion rather than Bell's palsy. That's why this is so important to know. All right, so we covered the facial nucleus. Now let's cover the hypoglossal nucleus because the same concept occurs. So it should be quick. We look at the hypoglossal nucleus, right? This is going to be the nucleus of cranial nerve 12. The upper portion supplies the tongue muscles, right? But which tongue muscles? The tongue muscles other than the genioglossus. So not genioglossus. So it supplies all the tongue muscles except not the genioglossus. The lower portion of the hypoglossal nucleus supplies only the genioglossus. That's the first thing that we have to establish. Upper, All the tongue muscles except genioglossus, lower, just the genioglossus. Now, let's take the same example here. Here is your right cortex. Here is your left motor cortex. Here is the hypoglossal nucleus. This is your right hypoglossal nucleus. This is your left hypoglossal nucleus. This is the right half of the tongue. This is the left half of the tongue. Okay, if we follow this step by step. Right corticobulbar tract comes from the right cortex, right? Makes its way down. As it comes down, what did we say before? It gives bilateral supply to the upper portions of the hypoglossal nucleus, but gives only contralateral to the lower aspect of the hypoglossal nucleus. The same concept would apply for the left corticobulbar tract, which we're going to do here in blue. It would come down. It would give what? Ipsilateral supply to the upper portion of the hypoglossal, contralateral supply to the upper, and then only contralateral supply to the lower hypoglossal nucleus. Same concept. You whack out that left corticobulbar tract. You take it out. It's done. Now, follow this through. If the left corticobulbar tract is injured, it's not going to be able to give enough supply to the right upper hypoglossal and the left upper hypoglossal nucleus, right? Via this thing, 1 and 2. You're not going to get enough supply. So this right corticobulbar tract, thank the Lord, it's still intact. And it's still able to fire and still stimulate the left hypoglossal nucleus, the upper portion, and the right hypoglossal nucleus, the upper portion. So even though this left corticobulbar tract is damaged, your right corticobulbar tract can still supply the upper portions of the hypoglossal nucleus due to the bilateral supply. But this third part here, this left corticobulbar tract, again, it's damaged. It's not going to be able to stimulate the right lower hypoglossal nucleus. This will be inhibited, right? Do you have a supply coming from the right corticobulbar tract to compensate? Let's follow it. No, because it also goes to the contralateral. So there's no black fibers coming to this hypoglossal nucleus on the lower portion. So therefore, if we follow this through, only this part, only this hypoglossal nucleus here, which is going to the genioglossus muscle, we'll just say right here. And then you have same thing coming over here from this left genioglossus muscle. Okay, if this genioglossus nucleus isn't getting enough supply because you damaged the left corticobulbar tract, it's not going to be able to fire its action potentials. And because it's not able to fire its action potentials, it's not going to be able to stimulate your right genioglossus. This left genioglossus nucleus, right, or the left hypoglossal nucleus, the lower portion, it's intact because there's no problem with the right corticobulbar tract. It's still firing. So because of that, it's still going to be stimulating, it's still going to be sending action potentials. And your left genioglossus muscle is still going to be getting some stimulus. Here's what's really interesting. Your genioglossus muscles, when they contract, they protrude your tongue out. But your right genioglossus, when it protrudes it a little bit towards the opposite side. And then your left genioglossus, when it contracts, it protrudes it a little bit forward, but also towards the right side. If I knock out the lower hypoglossal nucleus, if I knock out my left corticobulbar tract, which means I don't stimulate my right lower hypoglossal nucleus, I don't stimulate the right genioglossus, that means that this movement here is gone. I can't move the right I can't stimulate it to move the tongue forward and to the left. Now, the left genioglossus is the only one firing. And because it's the only one firing, when it protrudes the tongue, it's going to protrude it more in its direction because this muscle is weak or paralyzed. So now look at the deviation. If it's moving this way, what way would the tongue be deviating with respect to the lesion? The contralateral side. So that's important. So if you see someone who has contralateral tongue deviation, you want to think a corticobulbar tract lesion. All right, so that covers that, and that covers the corticobulbar tract in general. All right, Ninja Nerds, so in this video, we talk about the corticobulbar tracts. I hope it made sense. Ninja Nerds, we love you, we thank you. As always, you know what to do. Until next time.